Okay.
Mr. Linsky, I have a question.
Yes.
Have they ever tried dropping a... You said they dropped the feather and the hammer on the moon.
Yes.
Have they ever tried a balloon and a hammer? Because I feel like a balloon falls slower than a feather.
No.
If there isn't any air resistance, they should fall at the same rate. I do not think they tried that on the moon, but they did.
They really should.
Yeah.
The balloon wouldn't last long.
So, ladies and gentlemen, lesson 2, problem number 29 on page 83. A pitcher throws a ball horizontally at 41 meters per second. 41 meters per second is roughly, very roughly, 82 miles per hour. So the question is, if they throw the ball perfectly horizontally, how much will the ball drop vertically by the time it reaches the catcher, which is 17 meters away? So if I draw on the trajectory like this, if this is straight across, how much is the ball going to drop? While it's traveling to the catcher. All right, what is the acceleration in the x direction? What is the acceleration in the y direction?
What is the acceleration?
Now, if you're using positive, you're basically saying down is the positive direction, which is totally fine. Okay. What is the initial velocity in the x direction? What is the initial velocity in the y direction? What is the distance that the ball travels in the x direction?
17.
And the distance that it drops during that time
Is unknown.
is your question mark. And then the one thing that we could share between the columns is the time, and we don't know what the time is.
But they are equal.
But which column do we have enough information to get the time?
X.
In the x column. So we know that x equals VIT plus 1/2 AT squared. The 1/2 AT squared drops off because the acceleration is 0. So you're left with 17 meters equals the initial... Oh, no, we have the initial velocity. 41 meters per second times the time plus 0. And I saw a lot of you left that in fractional form. That's fine. Did anyone actually crunch it out? What did you get? 0.414. Okay, I'll just go like that. And then if you bring that time over, and you see how I kept my my calculation over here? Basically, this calculation was also on the x side. So not only do I list my data on the x side, but I put the calculation either on the left or on the right. So I keep all that distinguished. You know, the data and the calculations. So now I come over here to the right-hand side. I know that this here is going to be whoa, that's funny. 0.4146 seconds. And then basically I have x in the y direction equals VIY plus 1/2 AT squared.
VIYT.
Oh, yes. x of y is going to equal VIY, which is 0, so that whole first term goes. And then we have 1/2 times 10 meters per second squared times 0.4146 seconds quantity squared. And how much does that ball drop down?
0.86 meters.
Which is about 86 centimeters. And if this is a meter stick, it would drop between my fingers. It would drop that much. And that's in how much time? Less than 1/2 of a second of time. But even though it's going in so fast, doesn't have much time, gravity will still be pulling it down, and it would drop 86 centimeters. 0.86. Okay. Any questions, comments, concerns?